Alright, ladies and gentlemen, welcome back. Today we are looking at negative and zero exponents. Let's get into this. Okay, so the way I'm going to show you guys this today is actually by using a pattern. And we're going to start with first 2 to the power of 5. 2 to the power of 5 is 32. Okay, and now I want you to take a look at what is 2 to the power of 4. 2 to the power of 4 is 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. And we're going to stop there for a second, and I just want you to see the pattern as to what is happening between these numbers as we count down. And if you can tell me that these are all kind of getting divided by 2, then that's right, you are correct. Right? And so we're going to continue this pattern, so you can just tell me without having to do the actual work. You can say that 2 to the power of 1 is 2. And we're going to keep on going with that pattern. You're going to notice 2 to the power of 0 then, if I'm going to keep halving it, then 2 to the power of 0 will be 1. That's right. Now, let's keep going, and we're now going to go up to 2 to the power of negative 1. And let's keep following this pattern. You can double check this on your calculator if you want, but we'll just work on it using our patterns. So let's see, 2 to the negative 1 should be then 0.5. Right? 2 to the power of negative 2 should be 0.25. Then this should be 0.125. And finally, 2 to the power of negative 4 then should be 0.0625. And what I'm going to ask you to do is actually just pause this, pause the recording, and I want you guys to just double check all of these on your calculator. You can just do 2 to the power of and just make sure it's a negative, and just double check to see if these numbers are right. So, once you have checked it out, you guys have looked at it, I'm just going to kind of move this stuff over now to the side here, because I want to kind of show you guys something with the negatives. The ones that have the negative exponents. Well, with the negatives over here, and I look at 0.5, how can I rewrite that as a fraction? Right? I could probably just write that as 1 over 2. Now, just for fun, let's put an exponent there too with the 2. Let's put an exponent, so that could be 2 to the 1, right? What then would this be? Because this one is technically 1 over 4, but let's put this again as a fraction with a 2 as the denominator, and 2 to the power of what would give me 4? 2 to the power of 2. Hope you're starting to see a pattern here. How about this one? This one would be 1 over 8, or 1 over 2 to the power of 3. And finally, this one is going to be 1 over 16, or 1 over 2 to the 4. So what's the pattern that we see? What's the pattern that you guys notice? You see here, well, if this was a negative exponent, if I take the reciprocal, and then all of a sudden, the exponent becomes positive, and then I can work it out. See, 2 to the power of 2 to the power of negative 2. If I flip it, or take the reciprocal, all of a sudden it becomes positive, which becomes 1 over 4 and gives me the same number. Again, I want you guys to double check these with your calculator just to see that, then you can see that I'm not lying. I'm not telling you guys any fibs. Alright, check it out with this one as well. Look at that, 2 to the power of 3. And the same thing with the 2 to the negative 4. You flip it, it becomes 1 over 2 to the 4, and then you get 1 over 16. So, I mean, you guys can now see the pattern, and I guess what we can sort of come up with now is a general form as to what we can do. And you can check this out with any other numbers. You can do base 3, base 4, base 5, whatever you want. But basically what our beautiful rule is going to be that if I have a base and the exponent is negative, alright, what do? Well, it's just going to be the reciprocal, and it makes the exponent positive. Alright, check that out with any base. In fact, what I'll tell you guys to do is check it out with 3 to the power of negative 2. Okay, do that on your calculator. What is 3 to the power of negative 2? And then I want you guys to do 1 over 3 to the power of 2, or 1 over 9. Alright? and see how that works for you. Do you get the exact same answer? I'm going to leave that for you to do. All right? So you have a general, basic idea of what this rule is. I would suggest that you have this written down in your notes. All right? And let's just go on to the next bit where we take a look at fractions. All right, so how do we do this with fractions? How does this work? Well, if I was to break down this exponent, right? Because technically what I could do is I could put the exponents to both the numerator and denominator. So I would have 1 to the power of negative 2 over 3 to the power of negative 2. But here's the problem. They're both negative. We don't want these negative exponents. They aren't easy for us to work with. So instead, what are we going to do? Well, we're going to take the reciprocal. So we get now 3 squared over 1 squared, which is, sorry, I forgot my equal signs, okay, which is equal to 9 over 1, or is equal to 9. Okay, now, if you guys want to check it out, and if you don't believe me, I want you guys to do 1 over 3 to the power of negative 2, and see if you get 9. Because if you do, then you know I'm not messing with you guys. Alright, what's another short form of us doing that? What's a short way of this happening? Well, what if I did this? And I just flipped that at the very beginning and did that. Does that work? Well, we can now say then that it would be 3 squared over 1 squared, right? Which again is going to be equal to 9. So, I think that this works the same way. Alright. Let's see what would happen then if this works with the next equation, or sorry, the next fraction. Again, I would suggest try this on your calculator first, okay? And see if I'm lying. But outside of the calculator, what do? Well, we now found out our rule that if we were to just flip it, if we just flipped it, it made the exponent positive. So let's try the same thing here. So all I'm going to do now is I'm going to flip it. So the question is, though, sir, if we flip it, what happens to that negative? What happens to this negative? Does that change? Well, young ladies and gentlemen, it actually does not. Because the only thing that is changing when we take the reciprocal is the exponent. It has nothing to do with that number. So we're not going to change that. So we're going to put that negative right back in there. And it is now going to be to the power of 4, which this is now going to be 8 to the power of 4, which is 4,096 over 3 to the power of 4, which is 81. All right? And I believe we cannot reduce that any further, so that's it. We're done. All right. Now, how about this one over here? This is 3 over 5 to the power of 0. Well, I'm going to ask you guys to check this on your calculator first of all and see what you get. All right. Hopefully you paused it and you checked it. If not, pause it and figure it out. Good. If you got it, the answer is 1. Exactly. Anything to the power of 0 is 1. Anything to the power of 0 is 1. So, let's recap now. And let's come up with our negative exponents and our 0 exponent rules. Alright? So, if we've got x to the power of a negative exponent, all we have to do is just take the reciprocal and the exponent becomes positive. If we've got a fraction, whatever it may be, and that's to the power of negative exponent, we just have to flip that. Now remember, if there was a negative that was over here, we don't move that at all. It stays exactly where it is. The only thing that changes is just the exponent. And last but not least, any base to the power of 0 is equal to 1. And you can try this with any single number you want. Put it to the power of 0, it will always be 1. So these are your rules. These are your laws. This is what you live by for this section. All right? Hope you enjoyed it. Take care.